which is the smaller version of our Arduino series. Thermal sensor or infrared sensor using MLX 9614, and serial LCD 2x16 and buzzer. So this is the diagram of our contactless thermometer. We have the Arduino Nano, which is this one. We have the contactless thermal sensor for measuring temperature, which is this one. This one, which has 4 terminals, which later I will discuss what are those 4 terminals. And we have LCD display, which has 4 terminals also. Now for Arduino Nano, we know already, those who are using Arduino, that it has analog and digital I/O port. So all those level with A0 to I think E5 are all analog input output port, and D0 to D13 are the digital. For our sensor, so based on, if you refer to our manual, see, we have here a slots, or what is this, what you call this, nuts here, nuts. If you position like that, so there are 4 terminals like this. See, if I expand the terminals like that, so this is the nuts, here. Upside of that is the ECL, or ECL. Besides that, these pins are SDA, the data. This is the clock, the data. And here is the ground terminal. And what I'm holding now here, the 4th terminal, is the VCC. So in our diagram here, you notice our SDA, which is this one will be connected to our A4, or analog 4 output input, or I/O port, and our ECL is connected to our analog 5 I/O port of our Arduino Nano. And of course, the ground connected to our ground, and the positive VCC. This is our, by the way, this is our VCC. This is our ground. So simply connect the ground to ground, and VCC. The by the way, the supply voltage of this one is 3.3 volts. So what are those resistors here? A value of 4.7. This is a pull-up resistor. Which is connected to our ECL and SDA. So these pins we will pull up to 3.3 volts. So if you have any question regarding pull-up, you can just refer to any book serial. There are 4 terminals also: ground, VCC, SDA, and ECL. Notice that both of them have SDA and ECL. So conventionally, we connect this SDA and ECL in different pins here. For example, we are using another pins for SDA and ECL for other device. But here, notice that they are serial. So each serial device has its own address. So based on that idea, I connected the SDA and ECL at the same pin. Here, the SDA here is the same as the connection of our SDA for our sensor. So you see, this is your SDA connected to here, and our SDA is connected together to connect to the analog for IO port. And our ECL here, see, our ECL is also connected to our ECL here, which is the same connection with the analog 5 IO port of our Arduino Nano. Why is this so? This is because in our program, we will just define the address of this two. So we will make sure that the two have different serial address or address. So even if they are connected on the same pin, this pin will be multiplexed or will be used by two different serial devices, provided they have two different address. Here, see, our serial monitor, serial LCD. This is my Arduino. This is my sensor, which I soldered to the strip board because I want to make it fixed. It's so that it will not be. We are not using breadboard already, so here we'll solder based on this connection. So this is my finished product. Okay. Now, for our program, we are using, since we are using serial devices, for simplification of Arduino program, so that it will not be long, we are using libraries. So for the library, we are using i2 master library, which you can download at any GitHub sites. Wire.h library. These two are for our contactless thermometer, and since you are using also the I2C device, the serial monitor, serial LCD, we are using also the liquid crystal I2C.h. So this is what I'm saying to you here. The address of our LCD is 0 times 27. Actually, you can change this address by modifying these pins here in your LCD. If you can see here, I cannot see. There is here, this one, this. So these are the jumpers here, which you will modify in order to change this address. This one, you can make it 05F, something like that. The device now. The device, if I will power this up. Yes. You can power this using battery power, but I'm powering it with my PC. So it will be initializing. See, now since there is a light here, so it will be detected by our thermal sensor. See, it can detect more than 38 degrees or 39. Is it this to 39? It will give you an alert, fever alert. See, So you can calibrate the sensor in your program based on your requirements.